Right now, the streets of Naples are alive. Espresso machines hiss in cramped cafes, tourists crowd the waterfront snapping photos of Mount Vesuvius brooding across the bay. That iconic silhouette, the volcano that buried Pompeii, looms over every postcard, guidebook, anxious thought living here. But Vesuvius isn't the volcano scientists are watching. The real threat isn't on the horizon, it's beneath your feet. West of Naples, hidden under neighborhoods and ancient ruins, lies a 13-kilometer-wide crater R, a supervolcano caldera called Campi Flegrei. Right now, after decades of quiet, it's giving the loudest warnings in 40 years. More than 3 million people live atop this caldera or within its blast zone. The ground is rising at the fastest rate since 1984. Thousands of earthquakes rattle the center. Italy's National Institute of Geophysics and Volcanology, INGV, has raised the alert level. Evacuation plans have been quietly updated. The caldera is restless, breathing, awake. Most people have never heard the name Campi Flegrei. Scientists have been watching it for centuries, and what they've learned should concern anyone within 100 kilometers of Naples. So what exactly is happening? In recent months, Italy's National Institute of Geophysics and Volcanology confirmed ground deformation at Campi Flegrei has accelerated to rates not seen since the early 1980s. Pozzuoli, the town at the caldera's center, has risen over a meter in the past decade. In recent months, the ground climbs centimeters per month. A study in Nature and INGV press releases document the shift. Seismicity increasing, gas emissions changing. The swarm of small earthquakes that once came in bursts now comes almost daily. Italy raised the alert level to yellow. The government updated evacuation protocols for the Campi Flegrei zone, the first major revision in years. Scientists aren't predicting an eruption, but they're no longer willing to stay silent. Before we dive into what's happening now, let's be clear what this video will and won't tell you. You clicked because the title sounded alarming. That's fair, it is alarming. But this isn't going to be guesswork or hype. We're going to cover what a supervolcano actually is and why Campi Flegrei qualifies. The science of why the ground moves. The real historical track record, not just the disaster scenarios. What scientists honestly know and what they don't know. And what people in the region, and anywhere near volcanic risk, can actually do. Most people, even in Naples, don't know they live on a supervolcano. By the end of this, you will. You'll understand the science better than most headlines. But first, I want to hear from you. Have you ever visited Naples, Pompeii, or the Amalfi Coast? Have you felt a tremor, seen the Roman ruins at Pozzuoli, or heard locals talk about the ground moving? Let me know in the comments. I read them all, and your personal stories help paint the real picture here. If you think this information should reach people who live in or travel to this region, hit subscribe and drop a like. It tells the algorithm to show this to exactly the people who need to see it. Ring the bell so you're here when we cover the next monitoring update or dive deep into the science behind the other hidden threats most people completely ignore. Now let's rewind the clock, because Campi Flegrei's most recent eruption holds the key to understanding what might come next. Autumn 1538. West of Naples, the countryside rolls in gentle hills dotted with fishing villages and farmland. Lake Avernus, the Romans believed it was the mouth of Hades, sits dark and still among olive groves. Life moves to the rhythm of seasons, tides, the ringing of church bells. Then the signs begin. For weeks, maybe longer, the farmers notice something wrong. The ground shudders beneath their feet. Not the sharp jolt of an earthquake, but something deeper, continuous. The lake at Avernus starts to shrink, steaming with foul gases that smell of rotten eggs. Fish float belly up in the shallows. Wells that have given sweet water for generations suddenly run dry or turn bitter. The people are afraid, but they have no words for what's coming. This is Renaissance Italy. Volcanoes have mountains. Vesuvius looms across the bay. Etna towers over Sicily. Here there's only farmland, fishing boats, the ancient Roman ruins slowly sinking into marsh. No one has a framework for a volcano with no mountain. September 29th, 1538. Night falls clear and calm. Then the earth splits open. A crack tears across the fields near the village of Tripergole. A red light spills out like molten blood. The ground heaves and buckles. What starts as a fissure becomes a chasm, and from that chasm rises something no one alive has ever seen. Fountains of lava shoot hundreds of feet into the air, glowing orange against the black sky. The roar drowns out screaming, drowns out prayer. The air fills with the sulfur stench of hell itself. Ash begins to fall, first fine as flour, then thick as snow, then heavy enough to collapse roofs. People flee in pure terror, some toward Naples, some to the boats, some deeper inland, anywhere away from the fire pouring out of the earth. Behind them, the ground keeps rising. What was farmland at sunset is becoming a mountain by dawn. The eruption rages for a week. 7 days and nights of fountaining lava, boiling ash clouds, the earth reshaping itself like wet clay. When the sun tries to rise, the sky stays dark at noon. Ash falls across the countryside like gray snow, burying crops, poisoning wells, coating everything in fine volcanic grit. Pietro Giacomo da Toledo, a local friar, writes that the world seemed to be ending, that the fires of judgment had finally broken through. Then, as suddenly as it began, it stops. Where farmland once spread stands a new mountain. Monte Nuovo, the new mountain, 120 meters tall, built in a week from nothing. The medieval village of Trepergel lies buried beneath its slopes. The coastline has been redrawn. The mountain steams like a sleeping beast, too hot to approach, a permanent monument to 7 days of terror. For centuries afterward, Monte Nuovo remained a curiosity, a freak of nature, a one-time catastrophe in a quiet corner of Italy. But some minds don't let mysteries rest. In the 1800s, geologists began noticing patterns. The arc of low hills west of Naples, the scatter of small craters, the way certain stones seemed out of place as if hurled from somewhere else. At Pozzuoli, they studied the ruins of the Roman temple of Serapis, with its marble columns riddled with holes from marine mollusks, holes positioned 15 feet above the current sea level. The temple had been underwater, then lifted up. The ground had sunk, then risen, in cycles older than memory. In the 20th century, scientists started connecting deeper clues. Ash layers buried in the soil, far older than Monte Nuovo, chemical signatures that matched across hundreds of square kilometers. Slowly, the picture emerged of something vast and ancient beneath the countryside west of Naples. The Campanian ignimbrite eruption, 39,000 years ago, 200 cubic kilometers of material blasted into the atmosphere, enough to bury Rhode Island under 60 feet of ash. The eruption column reached the stratosphere. Ash fell across the Mediterranean from France to Turkey. The climate cooled. Some scientists think it helped drive the Neanderthals toward extinction. This wasn't just big. This dwarfed Vesuvius, Krakatoa, Mount St. Helens by orders of magnitude, one of the largest eruptions in the last 200,000 years. After that cataclysm, the ground collapsed into the emptied magma chamber, forming a wide caldera, now partly flooded by the Bay of Pozzuoli. Monte Nuovo wasn't a mountain at all. It was just the most recent vent in a volcanic system so large it had no single peak. The paradigm shift was profound. Campi Flegrei isn't a volcano, it's a supervolcano, a system so vast it doesn't build mountains. It erupts from scattered vents across a wide caldera. And when it truly awakens, the eruptions can alter the planet. In 1538, only a few hundred people lived near the caldera. The eruption killed perhaps 24. Today, more than 3 million people live in the same zone, and the caldera, after 485 years of silence, is stirring again. To understand what that stirring means, we need to understand what a supervolcano actually is and how Campi Flegrei breathes. Start with the basics. A caldera isn't a mountain, it's a crater, but not just any crater. Picture a massive underground chamber filled with molten rock. When that chamber empties in a catastrophic eruption, the ground above has nothing to support it. The earth collapses into the void, forming a circular depression that can stretch for miles. That's a caldera. Now, supervolcano, it's not an official scientific term, but it's widely used for calderas capable of VEI 7 or VEI 8 eruptions. VEI, the Volcanic Explosivity Index. Think of it like the Richter scale for eruptions, but logarithmic. Each step up means roughly 10 times more explosive power. Let's put that in perspective. The eruption that buried Pompeii in 79 AD, Vesuvius, at its most famous and deadly, was a VEI 5. Mount St. Helens in 1980, which blew the top off a mountain and was heard 300 miles away, was also VEI 5. The 1538 Monte Nuovo eruption we just described was VEI 3, tiny by comparison. Campi Flegrei's ancient eruptions, 39,000 and 15,000 years ago, were VEI 7, supervolcanic scale. What does VEI 7 actually mean? The energy released in the Campanian ignimbrite eruption was equivalent to hundreds of times the largest nuclear weapon ever tested. Think thousands of Hiroshima bombs going off every hour, for hours. The eruption column would punch through the troposphere into the stratosphere, 30 miles high. Ash would circle the globe within weeks. Regional climate could cool for years, a volcanic winter. The immediate blast zone would be uninhabitable. We're not talking about a disaster. We're talking about a civilization-ending event across a region home to millions. But here's what makes Campi Flegrei especially unnerving. It doesn't sleep quietly between eruptions. It breathes. The technical term is bradyseism, from Greek meaning slow movement. The caldera floor rises and falls in cycles that can span decades or centuries. At Pozzuoli, scientists can trace this breathing in the Roman ruins. Those marble columns of the Temple of Serapis, riddled with mollusk holes 15 feet above current sea level, are geological evidence that this ground has sunk below the waves, then risen again multiple times. Modern science understands what drives this breathing. Beneath the caldera, magma moves. Hydrothermal fluids, superheated water and gases, circulate through fractures in the crust. When pressure builds, the ground rises. When it releases, the ground subsides. Picture the caldera as a massive, slow-breathing lung, or a lid on a boiling pot that lifts and settles as steam pressure builds and escapes. When pressure builds, the ground rises and earthquakes increase. When fluids migrate or gases escape, the ground can drop. Here's the crucial point. Bradycism doesn't always mean eruption is imminent. It means the system is active, alive, responding to forces deep below. But active doesn't equal explosive. The proof is in recent history. From the 1970s through 1984, Campi Flegrei experienced its most dramatic Bradycism crisis in centuries. The ground at Pozzuoli rose over 1.8 meters, nearly 6 feet. Thousands of earthquakes rattled the town. 40,000 people were evacuated from the worst hit neighborhoods. And then, nothing. No eruption. The crisis faded. The ground even subsided slightly in the following decades. That's why the current episode is being watched so carefully. The rate of ground uplift and seismicity is approaching those 1980s levels, but scientists learned from that false alarm. They're monitoring more closely, with better instruments, asking more sophisticated questions. The science tells us Campi Flegrei is active, powerful, and unpredictable. But here's the part that should truly unsettle you. The stakes today are nothing like they were in 1538 or even 1984. The stakes today are nothing like they were in 1538 or even 1984. In 1538, when Monte Nuovo burst from farmland, the area west of Naples was countryside. Fishing villages, olive groves, scattered farms. A few hundred people lived near the caldera. When the earth split open, 20-something died. A tragedy, but contained. Fast forward to 1984. Pozzuoli was a modest coastal town. When the ground rose 6 feet and earthquakes rattled buildings, 40,000 people were evacuated from the worst neighborhoods. Disruptive, yes. Manageable, barely, but manageable. Today, the Naples metropolitan area is one of the most densely populated regions in Europe. More than 3 million people live within the immediate blast zone or close enough to face ashfall, infrastructure collapse, evacuation chaos. Pozzuoli itself now holds 80,000 people, sitting directly over the most active part of the caldera. The town's waterfront has risen and fallen meters within living memory. Residents joke darkly about the ground that breathes, but 80,000 people aren't evacuated with a few buses and temporary shelters. Look at what's at stake now. Naples proper. Nearly 1 million people packed into narrow streets and centuries-old buildings. The port of Naples, one of the busiest in the Mediterranean, handling cargo for half of southern Europe. The highway networks that connect Italy north to south. Rail lines carrying millions of passengers annually. Hospitals, schools, universities. NATO's Allied Joint Force Command. Archaeological treasures from Pompeii to Herculaneum. Museums housing artifacts that survived Vesuvius only to face a potentially larger threat. Even a moderate eruption, VEI-4 or VEI-5, far smaller than Campi Flegrei's ancient superblasts, would devastate this region. Pyroclastic flows, those deadly avalanches of hot gas and rock, could reach populated areas within minutes. There would be no outrunning them. Ashfall would collapse roofs across the metropolitan area, blanket farmland for hundreds of miles, poison water supplies, shut down airports across southern Europe. INGV and Italian Civil Protection have run the numbers. They've modeled the scenarios, and the projections are sobering. A worst-case VEI-5 or larger eruption could render large parts of the caldera uninhabitable for years, maybe decades. Hundreds of thousands of people would be displaced permanently, not evacuated for weeks, but relocated for the rest of their lives. The economic cost could reach tens of billions of euros. If evacuation fails or comes too late, thousands could die. But here's what really keeps emergency planners awake. Even a failed eruption could trigger catastrophe. Sustained unrest with no actual blast, just ground uplift, earthquakes, gas emissions, could force mass evacuations anyway. The 1980s crisis offers a preview. Parts of Pozzuoli never fully recovered from that episode. Businesses closed, families left, property values collapsed and stayed collapsed for years. Now multiply that by a factor of 10 or 20 across an area housing millions. Economic paralysis, long-term population exodus, the slow death of a region that took centuries to build. If you've ever vacationed on the Amalfi Coast, toured Pompeii, or dreamed of visiting Naples, picture this. Those narrow cobblestone streets you walked, those centuries-old buildings you admired, the metro tunnels that carried you beneath the city. Now imagine trying to evacuate millions of people on hours or days' notice through that same infrastructure. In a region where traffic is legendary and compliance with disaster drills is, let's say, inconsistent, where centuries-old buildings weren't designed for rapid evacuation, where the highways and rail lines that would carry people to safety also serve as choke points that could trap them. where the very density that makes Naples vibrant, the tight neighborhoods, the bustling markets, the layered history built on top of itself, becomes a liability when speed means survival. Now, if you're thinking, this sounds terrifying, does that mean an eruption is about to happen? Here's where we need to slow down and get honest about what scientists actually know. Ground uplift and seismicity do not guarantee an eruption is imminent. Let's be completely clear about that, because honesty is what separates real science from fear-mongering. The evidence cuts both ways. From 1970 through 1984, Campi Flegrei experienced its most dramatic unrest in modern history. The ground at Pozzuoli rose over 1.8 meters. Thousands of earthquakes rattled the town daily. Buildings cracked. Roads buckled. 40,000 people were evacuated from the worst-hit neighborhoods. Scientists watched, monitored, held their breath. Emergency plans activated. The world's attention turned to this quiet coastal town that seemed poised for catastrophe. And then, the unrest stopped. No eruption. The crisis faded like a storm that never quite breaks. Through the 1990s and 2000s, the ground even subsided slightly. Life returned to normal, or what passes for normal when you live on a breathing caldera. This proves the system can breathe intensely without erupting. Campi Flegrei can go through dramatic cycles of unrest that look terrifying but lead nowhere. So what's driving the current episode? That's where the scientific debate gets genuinely interesting. Is this magma rising toward the surface, which could precede an eruption? Or is it hydrothermal activity, circulation of superheated water and gases in the crust that can mimic magma signals but may never lead to eruption? Gas geochemistry studies give mixed signals. Some measurements suggest increased magma involvement. Others point to hydrothermal circulation. Seismic tomography, essentially ultrasound imaging of the underground, shows complex patterns that could support either interpretation. Ground deformation models are similarly ambiguous. INGV scientists emphasize they're monitoring continuously with the best instruments available, but they cannot predict if or when an eruption will occur. Only that the system is in a state of unrest that warrants careful watching. Now let's debunk some myths that bad headlines love to spread. No, Campi Flegrei is not overdue. Volcanoes don't run on train schedules. 485 years of quiet means absolutely nothing in geologic time. Yellowstone has gone 640,000 years since its last super eruption and could stay quiet for another million. Or not. There's no cosmic timer counting down. No, the current unrest does not mean a VEI-7 super eruption is coming. The most likely scenario, if eruption occurs at all, is something far smaller. VEI-3 to VEI-5. Comparable to or somewhat larger than Monte Nuovo in 1538. Devastating regionally? Absolutely. Globally catastrophic? No. The honest answer is that no one knows what comes next. The caldera could erupt tomorrow. It could erupt in 10 years. It could never erupt in our lifetimes. It could quiet down again, just as it did after 1985. Or the unrest could be the prelude to something serious that requires immediate action. The science is good enough to watch closely, but not yet good enough to predict with certainty. This is what separates real risk assessment from fear-mongering. The threat is real. 3 million people living on an active supervolcano is not a situation to take lightly, but the uncertainty is also real. We don't know what the caldera will do next, when it might do it, or how severe it might be, and that uncertainty is exactly why preparation matters. So if we can't predict the eruption, what can we control? History offers a powerful answer, and it comes from comparing how different societies face the same kind of threat. Nature sets the intensity. Human choices set the death toll. Look at Iceland's Reykjanes Peninsula. Since 2021, the region has experienced repeated fissure eruptions, magma breaking through the ground in spectacular lava fountains, exactly the kind of volcanic unrest that terrifies communities worldwide. The town of Grindavik, population 4,000, sits directly in the path of these eruptions. The ground cracks beneath houses. Lava flows threaten the main road. The local geothermal power plant, critical infrastructure for the entire region, faces direct threat from advancing magma. Yet the death toll from these eruptions is zero. Not low, zero. How? Robust monitoring detected the precursor signals months in advance. Scientists communicated clearly with authorities and the public. Evacuation orders were issued early and followed without argument. The entire town of Grindavik was evacuated multiple times as conditions changed. Residents grumbled about the inconvenience, but trusted the science. When the ground cracked and lava emerged, no one was in harm's way. Compare that to Campi Flegrei's challenge. The risk area is vastly larger. The population is 750 times bigger. The infrastructure is more complex. The evacuation routes more limited. The social dynamics more complicated. But the principle remains the same. Early warning systems work. Seismometers, GPS networks, gas sensors, satellite radar tracking ground deformation, but only if people trust them and act on them. Public education matters. Regular drills reduce panic and save lives. Land use planning that restricts development in the highest risk zones is politically difficult but scientifically essential. Italy has significant strengths. INGV is world-class, among the best volcano observatories on the planet. The monitoring network around Campi Flegrei rivals any in the world. Italian scientists understand this system better than almost any volcanic threat anywhere. But Italy also faces unique challenges. Economic pressure to develop every available square meter near a major city, cultural attachment to place that runs generations deep. Families don't easily abandon homes their grandparents built. The sheer logistical nightmare of evacuating millions of people through narrow streets designed for horse carts, not emergency vehicles. Political resistance to evacuation orders that might prove unnecessary. Economic resistance to land use restrictions that limit development in prime real estate markets. These aren't technical problems. They're human problems that require human solutions decided before the crisis hits. Campi Flegrei won't give us weeks of warning, maybe days, maybe hours. The difference between catastrophe and resilience will be decided before the ground splits open. In the investments made now in monitoring, the drills run this year, the conversations families have tonight. Which brings us to the question you've probably been asking since the beginning. What can you actually do? If you live in or near Naples, start with the basics. Know your evacuation zone. Italian Civil Protection publishes detailed maps online. Search Campi Flegrei Zona Rossa to find the official risk zones and evacuation routes for your specific neighborhood. Have a family communication plan. Designate meeting points both local and out of region. Choose family contacts outside Campania who can coordinate if local communications fail. Make sure every family member knows the plan and practices it. Prepare a go bag you can grab in minutes. Documents, medications, 3 days of water, flashlight, battery radio, cash. Keep it accessible and check it twice a year. Know your escape routes and have multiple options. Don't assume the highway will be passable or that trains will be running. Study back roads, coastal routes, mountain passes. If you don't drive, know who does and how you'll reach them. Follow INGV's monitoring updates at ingv.it. Sign up for civil protection alerts through your regional authorities. These systems aren't perfect, but they're your early warning network. Consider earthquake-proofing your home now. Secure heavy furniture, know the safest spots in each room, have emergency supplies accessible. If you feel sustained earthquake swarms or officials issue any kind of warning, don't wait for permission, leave early. For viewers elsewhere, understand that caldera and supervolcano risk exists in the United States too. Yellowstone spans Wyoming, Montana, and Idaho. Long Valley sits in eastern California. Valle's caldera is in New Mexico. The principles are identical. Monitoring, preparedness, respecting the science when it speaks. Support funding for USGS volcano observatories. Many are underfunded despite protecting millions of people. If you live anywhere near volcanic risk, the Cascades, Alaska, Hawaii, know your specific hazards and have a plan. General volcano preparedness applies everywhere. Stock N95 or 100 masks. Volcanic ash is fine, abrasive, and dangerous to both lungs and engines. Have water filtration capability. Know that ashfall can collapse roofs. Have a plan to clear it safely or evacuate before it accumulates dangerously. Protect electronics from ash infiltration. Keep offline maps and emergency contacts written down. Frame this as empowerment, not fatalism. You can't control the volcano. You can control whether you're informed, whether your family has a plan, and whether you take warnings seriously when they come. That difference between helplessness and readiness is everything. Let's bring this home. Campi Flegrei has been breathing for tens of thousands of years. It will exhale again someday. Maybe gently, maybe catastrophically, maybe tomorrow, maybe centuries from now. That's geology. That's nature. We don't get a vote on when or how it happens. But here's what we absolutely do control. Whether we listen to the scientists, whether we prepare our families, whether we build cities with resilience or with dangerous wishful thinking. The eruption, when it comes, will be an act of the earth. The death toll will be an act of choice. Choices made in city halls, in engineering firms, in living rooms tonight before the ground ever splits open. If you made it this far, you now know something most travelers to Naples will never learn. Beneath the pizza, the history, the stunning beauty, there's a giant, ancient, awake force. You're part of the informed minority now. Go back to that question I asked at the very beginning. Have you been to this region, felt the tremors, seen the Roman ruins? Share your story below. If this video gave you a new respect for the hidden powers beneath our feet, hit like and subscribe. We're covering the world's least known, most underestimated threats, one story at a time. If you know someone planning a trip to Naples or someone who actually lives there, share this video with them. Knowledge is the first line of defense. Picture this final image, the view from Naples across the bay, tourists snapping photos of Vesuvius brooding in the distance, beautiful and deceptive, while beneath the city's narrow streets, beneath the bustling cafes and ancient ruins, the real threat hums silently, breathing, waiting, alive.